Hello, you are welcome to Chemistry Explained series part 11. Today we're looking at a very important concept and topic in chemistry called the mole concept and Avogadro's number. Atoms are too small to be seen by the most powerful microscopes. It becomes impossible to weigh them individually. So chemists measure substances by weighing their mass. This helps us to determine the number of specified particles they contain. In chemistry, the amount of a substance is measured in moles. A mole is a number of particles, which may be atoms, ions, or molecules. The mole is the SI unit for the amount of a substance. So what is a mole? A mole is the amount of a substance that contains the same number of specified particles as there are atoms in 12 grams of carbon-12 isotope. Take note of that. Carbon-12 isotope contains a specified number of atoms, which are 6.02 times 10 raised to the power 23. This is a large number. This is also called the Avogadro's number of particles. This is the number of particles contained in 1 mole of a gas with a volume of 22.4 dm³ at STP, meaning standard temperature and pressure. That's also equivalent to 1 liter. This concept can be illustrated by using the things we use every day. Examples: when you have 12 eggs in a container, say it's a dozen. Whenever you say a dozen, your mind will go to 12. A dozen of book, a dozen of egg, just 12 in number. Then when you have 12 dozen, 12 times 12, that's 144, and it's referred to as 1 gross. When you have 5 sheets of paper, you call it 1 rim. So in the same way, chemists adopt the convention that 1 mole of any substance is equal to 6.02 times 10 raised to the power 23 particles. If you use a standard container to measure a cup of rice, for example, or a cup of beans, or a cup of grain of maize, they will have different masses, yet just a cup of it. That cup becomes a standard measure. So also 1 mole of hydrogen with a mass of 1 gram, 1 mole of carbon will have a mass of 12 grams. 1 mole of sulfur will have a mass of 32 grams. And 1 mole of silver will have a mass of 108 grams. Different masses, yet 1 mole, and they contain the same number of particles. Now, suppose we could weigh out 1 gram of hydrogen atoms. To get the same number of atoms of helium, we would have to weigh out 4 grams of helium, because each atom of helium is 4 times as heavy as each atom of hydrogen. In the same way, we get the same number of lithium atoms. If we want to get the same number of lithium atoms, we would have to weigh out 7 grams of lithium, because each atom of lithium is 7 times as heavy as each atom of hydrogen. Why is the mole concept very, very important? The mole concept is a fundamental idea in chemistry. It provides a convenient way to express amount of substances and relate them to each other in chemical reactions. It bridges the microscopic world of atoms and molecules with the macroscopic world of amounts, where we measure them in grams and liters. Whether it is water, salt, or gas, the mole helps us to calculate the volume, the mass, the molar mass, the number of moles in chemical reactions. Let's see some of the conversions involving the mole. Here you see the formulas, very basic 3 formulas we are going to use to solve 1 or 2 problems. Number 1, to calculate the particles to mole, converting particles to mole. The number of mole, you see the particle all over 6.022 times 10 raised to the power 23. Another important formula is how to convert the mass to mole. See the number of moles equal to mass in gram all over the molar mass. See the very third important formula. If you want to calculate the gas volume measured at standard temperature and pressure. So the formula is moles equal to volume in liters or dm cube, because 1 dm cube equal to 1 liter, all over 22.4. That's the volume occupied by a gas at STP. So let's see some of the practice problems. Number 1, how many atoms are in 3 moles of aluminium? It's simple. We go back to that formula 1. The number of particles, mole, particles all over 6.02 times 10 to the power 23. So by the time you multiply 3 moles by 6.02 times 10 to the power 23, you get 1.807 times 10 to the power 24 atoms. Then another question 2 is, what is the mass of 2 moles of water? We go back to formula 2. By the time we cross multiply, we'll find mass will be the mole times the molar mass. So 2 moles times 18 gram per mole with the molar mass of water will get 36 gram. Question number 3, convert 4.4 dm cube or 4.4 liter of CO2 at STP to moles. We divide that volume by 22.4 and we'll get 0.2 mole. So these are 3 key formula we use when we're dealing with moles and Avogadro's number. Let's have a summary. The table is there for the summary of all that we've said. The mole is a counting unit, like a dozen, but way bigger. 1 mole equals to 6.02 times 10 to the power 23 particles. This concept helps us to connect atoms and molecules to mass, volume, and chemical reactions. Mattering mole conversions makes stoichiometry, which will be our next lesson, and chemistry much easier. See the summary table. Thanks for watching. If this made the mole concept easier for you, give it a thumbs up. Subscribe for more chemistry explained series and leave a comment. Thank you.